Hello everybody, welcome to another stream. How are we all doing? I hope everyone's having a good weekend so far. So today what we're working on is this plan here. I don't know, I might need to zoom in, I don't know. So the plan today is we're going to be working on this like encoder generator management system. It sounds quite general and complicated, but it's quite simple really. We want to have a system where, so like when you do like formats, you basically need to follow a set of rules. And I would rather have those set of rules expressed in code that we could, when we run the generator, it goes, hey, you've broken the rule. And then like you go and do something which allows you to progress. So essentially we want to be able to, like, an example of a rule is you can't change a structure unless you bump the version. So we need to make the sort of versioning part of this system, but also like if you change the structure, we should know about it. So we're going to be trying solving these sorts of problems. There's more things like enum values, they can't change unless you bump the version. There's also some other rules. So how we're going to solve that is we need a system, or the system will make a .encdb file, which is like an encoder database file, which will contain all of the types and all of the versions that have ever been made. But we're taking the simple approach here, and this .encoder db file is basically, or it is identical for the most part to the .enc file, which we use to encode, or which we use to describe our data types. So we've described our enum here. It's very C-like, but we also support extra things like packing types. So we can define how we want it to be packed down, right? This 16-bit int gets packed into 8 bits within this range. And this float gets packed into 8 bits within this range here. Very terrible examples, but it's just an example to test out the system. So the file that we're going to have is going to look basically like this, but we might do some things to make it look different so people don't accidentally start editing it. We might say this is the database file or something like that. And maybe everything has an explicit version after it, V0, right? V1, V0, that sort of thing. So there's those things there. So yes, we already have code that prints out from a bunch of data types. We have a way of, after reading in this file, we can reprint out the same file, basically. It's a bit shuffled around, but we print out the same file. So we already have a way to serialize out to this sort of .encdb file, and we also have a way to read it in. So there's not too much code going on there. We would need to support a few more hash directives. So yeah, the way the system's going to basically work is we're just going to read in the .encdb file and then the .enc file, and we perform a sort of a merge, and the merge will produce some of the errors, and if there's errors it will stop, and then afterwards we will then code generate all of the custom encode and decode code. And the merge can fail if structures change without bumping a version, or enum values change and other things like that. So the whole point of this system is that we don't break compatibility when editing types accidentally, and we can provide a sort of on Rails approach and instructions for what to do. Because when I'm working on a different system, I've got my head really in some other part of the code. I don't have to sort of put some mental energy into remembering those sort of 3 or 4 rules. Maybe it's more, and not to break stuff. You know what I mean? So this system should help out a lot with that. So let's get started. I hope everyone's having a good weekend. Hey. So we're going to go over to that encoder generator. And we already read in the file, right? So what we would like to do, so we need a way to merge these, right? So we read in a bunch of like struts and enums. So really, we should call this what is this, like a type? I was going to call it type bag. I think I did it for the custom compiler. Let's call it like a token bag. Anyway, type bag. Let's do it. So we're just gonna have, because I think we've got to merge these two things, right? We'll have one. I could maybe call it type table. Yeah, let's call it type table. It's kind of a better name. Type table. Boom. So we have all our types in here. So we read the .enc file. That'll give us a bunch of types. And then we want to read the .enc database table. And that'll give us even more types. Wait, we'll read them the other way around. Yeah. And then we'll merge them. Good evening, Devastated. How's my weekend been? It's not been bad. Yesterday I was just chilling. Went to like a party briefly and, you know, ate some food. And then just dropped off some birthday presents, really. Been quite relaxing. Today I went to church. Yeah, that's about it, really. How about you? Hey, Buff Overflow, how you been? It's been a while. So we need to be able to link an identifier to either a strut or an enum, and we might have like tagged unions later as well. But yeah, I think we actually need to get my hash table going, you know. So we do a core string for the key, and we can do maybe a type. Yeah, there's this type thing. They have a type kind, and it would either be a strut or an enum, basically. So I think we'll have this way to take an identifier to type map. So this would be useful because I think the way we do our type name deduplication is we look over all of the struts and that's it. So technically struts and enums could accidentally be named the same thing right now. So we need to solve that problem. But yes, be cool. So we have this thing called a type table now, and we can do some merging of type tables. So yeah, we'll have one type table here. You'll have two type tables. We'll have the type table. Oh, then we'll have the database version, which has more of them in. So two type tables, they'll get merged. And yeah, so we need some convenience functions for those really, an initializer probably, and then a merge function. Should be pretty sweet. Oh yeah, I've been doing good. Thanks for asking. Hope you're doing well too. Thank you, thank you. Yeah. Wow, bought a house and moving in about a month. Amazing. It's a big thing. Awesome. Congratulations. Not many people get to buy houses these days. They're, you know, it's expensive. Everything's expensive right now, isn't it? So congratulations. That's great. So have you got like a whole bunch of stuff you got to move as well? Because thankfully, when I moved into mine, we didn't really have much, so we just moved in and had an empty house. But I can imagine it's like quite a pain trying to move a whole bunch of stuff. Someone I know recently moved, and they got movers to do it all, and they paid them. And she said, she's let, and they what I found quite impressive is they undid like a wardrobe, and then like took it over there, and then put the wardrobe back up. Crazy. For me, every time I take a wardrobe apart, it's never going up again. It's destroyed. So it sounded quite good. It sounded like a quite stress-free way of doing it. Maybe it's quite expensive, but that's what I'll probably do next time. Sounds pretty legit. Let's get some other people to do it. Yeah. Ooh. Right, so the problem having like parse type, right, parse type is going to end up looking in the. Yeah, you need to pass in a type table. Right, we'll get some things going. So let's just make two functions. One function is going to be the sort of type table in it. And the other function is going to be type table merge. Merge, we probably don't need any arguments in. Because what I'm thinking is that we only need we are going to be using the global data for that, so it should be okay. Right, seems all right. That's good. So I guess where's that initialization code? Let's just get that kicking off. We also need to instantiate the new hash table. Table ident to type. Allocator. The capacity 1024 ought to be good enough. Maybe we go higher. What else? We need a hash compare function. Sorry, no, a hashing function. So core fmv hash 64. Crying out loud, it's too smart. A key compare. So I've already got one of those. I think it's the core string. Right, key hash string. Right. Yeah, so core key hash string. Core key compare string. Nice. So I think that'll do it. So that'll initialize the hash table. So I have a proper identifier to type mapping thing. Sweet. We got a merge function at the ready as well. So we can merge two type tables together. So we'll do that later. Let's just correct some errors that we've introduced. So I think it's go to right bracket D in it. Next diagnostic. No, not that much stuff to move. Most of the furniture will be new for the house. Awesome. So be already there, so to speak. Cool. Yes, really nice having to move beds, wardrobes, and such. Yep. It's such a mission. Oh, it is. Awesome. Sounds pretty cool. Sounds pretty exciting as well. Upstream. Yeah, so we'll pass in the type table. Hey, Quisty. I discovered IPC, sorry, SPC, and in Helix for Dummies. Oh, space plus A. Perform code action. Oh. What does it do, code actions? I have not seen that one yet. Oh, I see. So if I go here, then I say A, it might automatically complete it for me, right? So that's what I might have been pressing a few times where it includes stuff at the top of the file. Right. I see. So it goes, it does a suggestion and you could do it. I see. Yeah. I prefer to do it manually, I think, still. Right, so you gen dots. And then the type string takes in another type table. Cool, so we corrected those diagnostic errors there. Has that got a... Okay, next diagnostic. What function are we in here? We're in parse type still. Oh no, parse type has the problem, right? So parsing a type, we would need to know the type table we want to put it into. So down here, we would simply like to be able to type table. Right, so after we've corrected all these problems, we'll be able to get our parsing function in its own function. Get the parsing code into a single function, and then be able to, separately parse two separate files, then we can merge them. That'd be pretty sweet. So printing will need a type table, will it? You only need to print when you do code genning, which means that will come from the database version. So we should, in this case, be able to say gen dot encode db data, encode database type table dot strut. Did it? Oh no, that was right. No. It was complaining because we need to pass in the type table. Right. Gen dot. Yeah. Anything else? Seems pretty alright. So parse and generate. That that should instead just be labeled parse. So parse file, type table, excuse me. Yeah, it works on the diagnostics, yeah. To be fair though, a lot of the suggestions in a C compiler at least are pretty crap. Yeah, because they mostly like say, oh, did you misspell this thing or something like that? Or, you know, would you like to include this file? But oftentimes you want to include it in the right place, you know. So having like the computer do it for you is just quite, it's just not the way I would do it if I'd solve the problem, if you will. Doesn't really save him much time, to be fair. Yeah, so now anytime we do sort of a gen dot, oh crap. So we want to say type table. Now there was a place in this code when we parsed up the structure enum and tried to see if it's already been declared. This is when we print it back out, isn't it? Right, this is some of the sort of CSON stuff that we've been doing. We could also just delete, I might comment this out because I don't need it. So the CSON writer and reader that we've been testing out. So we just got rid of that problem. I'm not fussed about solving it now. Because we'll be like rewriting the code we'll be code generating that sort of code. So it's good to keep it, but just not really keep it compiling. So one problem is when we parse up this file here, what I've discovered is that if we have a structure and an enum names the same thing, it will be allowed. It will then code generate it and then it'll be a problem. So we need to use that new hash table to do the stuff for us. So I'm thinking so I want to be able to do like a type table ident to type get. So we'll pass in an ident just to make it easier because the functions are a little bit weird to remember. And I'll have a setter as well. So I'm going to set based on some type. So I think it's like core hash table find kept paying, my friend. Thank you so much for the sub. 11 months now. Appreciate all the support. How are you doing? Damn it. These SOBs. Coming in here. For some reason doing that stuff, which I don't think works. Like who clicks on that and then what happens? I've never clicked on it. Also, I won't click on it. Don't click on it. Right, where's the keywords? Oh wait, no, this block terms. It doesn't support Unicode and these buggers. Right. It's always a new site as well that they do it on. Can we do like... See, the problem is they don't have a way to say Unicode characters, and probably because Unicode is so damn complicated. So I think what we can do is this. Regex is enabled. .rs on. Now that's a bit... It's then a space. And then a V. Dot star. All I know is my dot stars. Yeah. So cheap. They won't have Unicode P maybe. They typically do it on the vowels. Right. Let's give that a go. If not, we've got to get a whole new solution. Right, screw this guy. Or maybe not this guy. Screw the person who's using his account. Right. Done. Why make... Why not I'm making a that you can view it as an image and any variations get banned? Yeah. I know. Oh, like, why doesn't Twitch like have a way of like automating that? You know, it's a bit weird. Like, why doesn't Twitch have something built in that does that? Yeah. I don't know. Didn't say same mode, all good. That's great. As in Riss, welcome. Welcome, sir. How are you? Do you remember we should call this find? So anyway, it's like a find. We'll call string get type back. So crap. Yeah, you need to pass in the type table. Type table ident to whatever. Yeah, ident to type map. Pass in the identifier key, and we get ourselves a type pointer back. And it should return null if it doesn't. Right. Now, the set is going to find or insert. I forget the way this looks like. We'll call it insert. So bool is new. So we can return a boolean. Yeah. Right, so the second parameter is the key, the third one is the is new out. And we get back the type pointer. So this is DST. And what we're going to say is if it is new, we're going to say dst equal type and then return true. Else return false. You know, maybe I should have a function which does this for like anyway for my hash table stuff. Maybe I should have one where it says like find a reinsert and you can pass it in by value and it will do that. Oh, sorry, this was find or insert. Maybe I should just have an insert, insert if new or something. I don't know. But this will do for now. So where we need to do this. So someone just tried to post another message in the chat, but it looks like it didn't get posted. That's cool. There's another phrase as well, best viewers. Let's nick that one. These boys and girls doing this. Alright, so it's best. We'll dot star it. There we go, take that. I'll do it. Hopefully. Cool. So now we can correct that code right in that parse file function, or we parse up our .enc file, which has all our data types in there. We get all the type information. We do a thing. Hang on a minute. What are you doing in there? That ain't good. Right, yeah, hang on a minute. Yes, we should probably have a, you need to instantiate those type tables there. Where's the allocators been at? Oh, it's global, good. Gen, the encode file type table, and then the I actually didn't need to pass that one in, to be fair. It's global. And then the database file, the one which holds the history of all the types that we have. So essentially there's two tables there. So let's get back to that function. It's called parse. You know, maybe we should make another function. Actually, we'll call it generate, or parse and generate, like it was called here. And we could then do the whole thing, right? We could parse both files, try and do the merge. If we can't merge, error. And then this way we can end up just copy and pasting this line for every encode and decode file that we have. Which, yeah, that'd be pretty cool. Yeah, so it'd be like parse file. So we're going to parse the gen dot so this is the, we need to then have a char encode db path. So this is where the database lives. So sn printf into that buffer. That'll be string with a db on the end. So just a slightly different extension. So we need to read in two files and then do that type table merge. Now, say we couldn't read this for whatever reason, like it doesn't exist or something like that. We need to be able to like, well, what do we need to do? No, it's fine if we don't read anything, I think. But yeah, if this one fails to read, it would then just bail anyway. Yeah, so then it already would have exited the program and printed an error. Discards qualifiers, okay. Nice. To do the type merge, and then we would like to then basically generate the code. Generate, which might go here. This will do the generating itself. Then there'll be another one which is gonna... There might be another one which will then save out the table again. So save database. So after the merging, save back out to the database file, and that'll be good, I reckon. Yeah, so we've just got to fill in those. We're not going to fill in this function today. That'll be one for a future stream. But this is the general structure of the logic that we have for now. Is this a save system with metaprogram or also gen the C code for saving and loading? Yeah, so in the past I've done manually writing serialization code. I've automated it with having like a type table that I hand write out, and then I have like a serializer or an encoder, as I call it now, for text or JSON or binary or something, and it just operates on type information. But the problem I had with that is that I didn't like the debugging experience was very bad. Like if I had a bug, you would be deep down. There'll be like a encode strut function and encode like type function, which then switches on the type and then it does a strut or like an array one, and then like there'll be a few like encode and int. So what would happen is you'll just be many levels deep down here when you got a bug in one of your encoders in the stack. And if you're trying to like put a breakpoint down and figure out where the bug is, it's quite a pain. You have to put an if statement in and do a string compare or something, and then be like, put a programmatic breakpoint in, and it was really fiddly because you might want it on like the third one or something. So yeah, but I do like the fact that with the type tables, it kind of automates the process, right? I do like that aspect. So what I'm going to be doing is code generating the Slow Kenny, my friend. Appreciate the sub. Appreciate you, sir. So I do like that automating process, but I also like being able to have like actual functions I can stick breakpoints in for each type and see sort of the things they're actually serializing, right? They'll be like encode. I actually have an example here. The code will look something like this. So this is encoding a structure. It'll be like, I'm encoding this structure called strut field, serialize out the thing called type and ident. And I could just put breakpoints down in here, and it'd be a lot easier to debug, I think. So when I'm kind of merging the two there, I'm doing like a code generating thing. But we will code generate C code from this file here, and this file will give us everything that we need to generate text encoders and decoders, binary encoder, decoder, and maybe like, so one will be bit packed, and there'll be another binary one which will be like an in-memory packing and unpacker. And that in-memory one is going to be used for GPU stuff, so I can pack stuff on GPU down without having to be manually do it. I could just write it in this thing, and it should be very easy to tweak stuff and not have to try and get stuff correct 100% of the time. So yeah, that's what we're working on. It's going to be quite useful, I reckon, when it's done. Enumerator. Hey, you're not doing bad. I actually managed to get reasonable sleep last night. My wife started going to bed around 9:30, so it's quite alright. Woke up at 7 again though, obviously, because it's when the baby wakes up. But I caught up on some sleep. I still got some more to catch up on. But yeah, I hope you're doing well. Hey, Vimara. How you doing? Welcome to the stream. Thank you for the 50 bits in Imria. So I've already got the safe code here for this database file. Past Henry made this to debug. Prints out all the data we've extracted from the .encode file. So our database file is going to be in the exact same format, kinda. So we're just going to print out. It's going to be a little bit more explicit. It's probably going to have versions in there as well. We've got to add that in, but we'll get that going. Right. So this is generator encoder database table. There we go. So goes over all the enums, prints those out. Semicolon, my friend. You missed a semicolon. And then goes over all the structures and tables and prints out those. Cool. So it should be able to be parsed up again. We're missing a few more directives, but that'll be all right. Right. So let's sort out that identifier thing where it, duplicate. There's like a duplicate strut identifier. So it looks over here. So what we're going to do is we're going to say if type table ident find so we're going to look for S ident, so structure ident. If we manage to find that, then we have ourselves a duplicate. And we would have got the type. Oh no, sorry. This ain't got that much. It's not, it will print out where we are right now, but it won't print out where the other one is. That's okay. So we're going to do this exact same thing, but for the enums. So the enum is here. So we actually need to put it into the table as well. Wait, that's just a find. Yeah, actually it should be called an insert. So I need to be able to make a type thing. Type.kind type.enum index take type table enums data. Yeah, so actually thinking about it, the other one was a little bit wrong. That's all right. Oh, and it's been insert if we fail to not insert it, because it already exists. Cool. So that'd be a strut. Yeah, so we failed to not insert this type, then duplicate. Great. So struts. Cool. So that's corrected the duplicate identifier thing. So now if we declare an enum or a structure, they go into the same hash table so we can catch duplicates. That's sweet. And it should be a much faster sort of lookup there. So the thing is, though, is in the database file, that can have duplicates because things can have versions. So we're going to have to solve that problem. But we haven't really got there yet. But that will be something we're going to solve. So I think we'll get this up and running again. We'll code generate some stuff. We'll get it to generate the database file. We'll look at it, make sure it's got everything in there, and then we'll tackle the problems individually. So we're getting close. Let's go to the next diagnostics. Right, so something else is failing that. Right. Okay. Type table. So this is when we parse the structure fields. Let's go to next diagnostics. Right, that's it apparently. Apparently it's all going to compile fine. Maybe. So right, so this should save out this new encode database file thing after trying to parse it. The merge is going to do nothing at the moment, but that's okay. So let's quickly make sure we got everything in there. I think I was missing something on the structure fields, like it wasn't put in the is hex down, or this is hex directive. We need to put that in there. So what we actually need to do so print to standard out. That's not right. So we need to actually open up a file. File. No. Char star path. File. F. F open. Path. WB. Right, it's not Warner Brothers, it's right binary. And we just need to assert to make sure that is open. Nah, we'll do the assert, I think. Failed to save out DB file, something like that. Be alright. I failed to open in write mode. She's been doing alright. Reading about the compiler optimizations now, so it's been fun. Awesome. Yeah, it's interesting. I remember looking at into some of that as well. Yeah, it's pretty cool. It's pretty cool stuff. But also, there's many different levels of optimization. You do optimization in the syntax tree, optimization in the IR, optimization in the... You lower it down to another intermediate representation, which is closer to the assembly, and they optimize for like register usage and stuff. And yeah, there's lots of yeah, optimizations as you go down. Yeah, so now we sorted that out. Let's just quickly pass that in here. The encode database path. Right, it's just a text file. It's a great database. So here we're going to say if is structure field is hex. We'll print out the with a bit of a space first. We'll print out hex like that. And at the end, we'll do the semicolon and new line. Now I need to remove those new lines here because I didn't do that. Cool. Yeah, so we need to replace standard out with a bit of F, you know. So that's cool. So any more sort of directives that I'm bringing in that I'm not printing out. So there is that dev mode thing. Maybe we should be printing that out. Yeah, there's dev mode. That's about it, isn't it? Yeah, that's okay. Right, I think we're okay. Where we're at. Let's go ahead and give it a run and see what happens. So, scripts, encoder generator.sh, which compiles and runs the C program, and it'll just read the files and generate. So hopefully that goes. But got K. Why was that file made? See, it doesn't even exist. So that was weird. Did it F? Right, we read in the whole file and we don't even check success. If success, if not success, we'll just return. Now I don't think we care if it's the cool. So apparently that just worked. So our database file, it's empty. Because somebody... Yeah, why is it empty? That's bizarre. Yeah, do an fprintf, right? Do an fput. We didn't do a close though, but still. Oh no, because the encoded database type tables, these aren't even right. Okay, so I think we'll gotta write the merge function. That's all right. We'll start writing the merge function, and we'll just improve it. So type tables merge, right? We're merging the one on the Reddit and the database file. So here we can look into that. So there is a thing called exit reader error. So we say exit location error, I guess. Lock, and it will be lock bar path, lock line, lock column. So location. We're going to be needing that. Cool. So let's go to the merge function and get going. So what a destination table and a source table. Bit of a DST, that is going to be gen.database. Just making some shorthand pointers, you know, making it a bit easier. And the non-database one. So yeah, we're going to go over all the types, put them into the database if they don't already exist. If they already exist, resolve any issues if we can. If not, error. I need to go. See you later. Cheers. No problem, Joe. Stay. Have a good evening. Thank you for popping by. Yeah, hope you have a good start to your work week, sir. Yeah, should do it if it's a little overwhelming, but still lots of fun. Cool. Helps that I have no idea what I'm doing. Yeah. Well, you can write your own little like IR and give it a go, right? Yeah, it's just basically transformations, isn't it? Yeah, just transforming stuff, yeah. Right, still going. So, say if we've got so do we go over all the enumerations? Right, if we go over all the enumerations in the source file and we get their identifiers, try and put them into the other to the database. If it doesn't exist, it's okay. If it does exist, we compare all the yeah. Must be all right. So where's that saved database file? This one. This has our for loops already done for us. Copy paste. There we go. So go over all of the source enums. Source struts and tables. So this was obviously doing printing. We're not doing printing here, so we could probably get rid of this printing code. So the idea is we want to say, right, type table right, there's a function that we don't have. Yeah, these two. Type table insert. So insert into the hash table. We would like to insert that type. So we need to get that type at the ready. So I think we damn it. I think we need to find it. first. So find it first. Or worry about the construction in a bit. If found, right, if we've not found a type. Oh yeah, so if we've found a type, I guess it's just if and else. Yeah, it's two separate things. So the easiest one is we haven't found it. So we need to insert. So we'll push destination E for enum. We'll do a core stack push. What do we even need to? I don't think anything needs to get patched. Yeah, it should be okay. Like, we don't need to move all the fields over. It should be fine. Like all the enum values. Yeah, so I think we could just say core stack push. Will be a deref the pointer it gets back. So we'll push on to source enums. No, sorry. Destination enums. You know, we could put the const here to stop us from messing that crap up. But maybe... No. We haven't got const everywhere else, so any good idea. Right. We're pushing into destination enums array. And I want to store the dereference of E. So we're just putting the enum in there. And then we've got the insert, the new enum index, which will then be core stack count of destination enums. So we'll just append it on and voila. So I think that's the logic you want, right? If you haven't got it in the database file, it's a completely new type, right? Okay. So this here is going to be enum index, and then we literally just do that. Type table, ident, insert into destination, ident, and type. Voila. So that's the easiest one. Now, if it already exists in the database, what we need to do is simply we've got to check a few things, right? Let's get to the actual file so it becomes a bit easier. So the thing is about enums, the rules are, unless you up the version, you cannot... There's this sort of dev mode thing as well that I've got. But so if you up... yes, so the way you up the version is you put it into dev mode, you make your changes, right? And then you make your changes, and then you come out of dev mode, and then that will solidify a new version. So if you're not in dev mode, you need your if you're not in dev mode, you need to check your check the enum values, make sure they have the same number, and then make sure all of them have the same name and same values. And if they don't, there's a problem. So we probably would just So we'll probably actually just go over all of the values here, and we'll probably just do like an n squared. Should we do an n squared? Kind of sucks. See, if we store hashes, n squared won't be that bad. We're still n squared, but yeah. But I don't think our enums are going to have massive amounts of values, so squaring it might not be that bad. So we'll scan over. So we could probably make it such that we have a linear array of we could just hash right, so with enum values we'll probably have their sort of like hashes, value hashes, so their names basically. Well, it could be their name and their value hashed up, and if the hash is different, no, we'll need two sets of... Yeah, no, we'll just hash up the ident in this case. So it's be a U64 array. And we'll do the same thing for structured fields, we need it for structures too. So that way it's just a quick check and we're not checking a bunch of strings all the time. So when we push on for these here, well, when we allocate them, cool. So we do a get next push pointer. Right, this is where we actually do the push. Verify, identify, good. Right, so here we're gonna just chuck on the hash. So it'd be like a core FNV hash 64. The bytes are going to be the string. Well, it's, you know, we've got to do a proper... Wait, have we got a hash function for it? Hash string is kind of a void pointer that kind of sucks, but well. I'll do it. Yeah, so if you need a hash function as well. It's not really a proper FNV hash as well. We do it that way. Right, I might make a function for it. So with my string stuff, we should probably have a way of just saying, hey, you know, hash this string for me, please. U64 core string hash. Be quite easy. We'll do it properly, right? So realistically, you need to instantiate with the initialize constant, which is some prime number, like that. And then you need to really actually hash two parts of it. You need to hash the length and the data itself, because if you just hash the data, you're more likely to get into so if you hash, let's just write it out and I'll say what I mean. Address of string size. Cool, so that you pass in that hash there, and then we keep it going, keep hashing the hash by passing in the data pointer with the length or the size. So if you just had that one where you just hashed the data, right? So you're comparing. The whole point of the hash is you want to have a quick, easy compare where you can get like a quick, easy compare where you can compare two hash values and check for equality or not. And there will be collisions. So to help avoid that problem, so if we just had this one, you're more likely to get collisions if you just with strings with different size. If you encode the actual, if you hash the actual size as part of the hash as well, it will help not get collisions basically, because you're hashing more data, and this size kind of relates to the data of the string as well. So the size would be different for a string which is like 3 big versus a string which is 8 big. So yeah. Because I've got more collisions if I don't do this, basically. I've seen it in the past. And the FMV hash is like, it's a fast hash, but it isn't really that. It has more collisions. So we've got a nice little function now for that. So we can just use that instead. And we can pass in the identifier here, like that. Oh crap. Cool. So every single time we push on a new structure field, we can push on its hash. So now I've got a linear array of hashes. So when we're doing this more expensive, you know, it's kind of like an n-squared algorithm. It should be a lot quicker and hopefully less problematic, the fact that its complexity is n-squared. That's the hope. So this one is the enums instead. No, it's not. This one is. Cool. Right, so let's go back to that merge code. Right. So when we've found an enum that already exists, we go over all of the values for the source enum. Now, really just calling it E is kind of a bit crap, considering we're going to have like a destination E as well. Cool. So if we want to go over and see if we'll go over all the source ones. So before we go over and do anything, we should really just say if destination enum, destination found type if found type kind is not equal to type kind enum. This is our first error we're actually going to write. So exit location. So we'll be like source enum location. And this is going to say enum with this name has so in the past there's been something called is in the database as a strut or table, right? So please use a different identifier. Well, I guess another solution would be you'll be able to sort of like mark this as a or maybe you have ways to remove the old stuff, but I don't know. We'll just do this for now. If it becomes a problem in the future, we'll actually solve it, but for now, we don't need to. So we'll pass in like oh, for crying out loud. Right, so we need to do that sort of like int casted source enum ident size source enum ident data. Then I wanted to do a bit of a found type. Have we got kind strings yet? I don't think we have. No, let's get one of those lookup tables quick. Static const char star. Type kind count. Right, that'll do. So we could take this lovely thing here and then go to the merge function and throw that in here like so. Found type kind. Right, so that's a nice error message there. Happy with that one. I doubt we'll probably ever get that error message, but you know, you gotta handle all your cases. So after we've done that, we now we want to say is if the source enum values count is not equal to the destination enum's values count, a field has been deleted or removed. You know, it would be better if we find the actual one, right? You know, which one it actually is, right? That would be better. you know, so we can say if it's not equal, so we can say if it's less than, find just one that doesn't exist or whatever, right? We can find all the ones that don't exist. But then you could always add then remove some and the number would stay the same. Yeah, so maybe if we just do that thing where we so we should go over all the destination ones, then go over all the source ones. See if you can find it. In there. Hmm. Gets quite explosive with the number of for loops if we keep doing this. Hmm. Right. So here we're just going to say, oh. So we'll say if right, if value ident hashes. So when we parse those types, parse type, oh no, not that one, push, that's it. So when we add a structure field, we need to put on here that, here. So here we're about to go parse all the structure fields, and we need to say what is the next pointer of the object you're going to push on. For those field I think my telesense is busted because I had some code unfinished. Right, so the same thing for the enums down here. Value ident hashes. Right, so in that merge function, here it is. So in that merge function, we can now say, right, destination enum value ident hashes. I guess we can preload that. Hey, original Raven. Looks like you changed your own message about identifiers and hat, and now there are some words missing. Oh. Where was that? Was that back where I was? No, here's fine. Well, you mean these ones? Is this what you're saying? So I've just done a new line and done a hint, that sort of thing. These are just hints. So the errors are a little bit more friendlier. I don't think I messed anything up. Hey Shiloh, how are you? Welcome, welcome. So this would be the source one. Source enum, source enum value. Right, so if the destination ident hash is equal, we found a match. And then we break. So we then just say if we have a source EV, if we like enum value, if we don't have a source enum value, that's another error. No, okay. I'm great, enjoying Sunday, but doing absolutely nothing useful. Amazing. Yeah, relaxing is good. It's good to just do absolutely nothing. Just shut down and put on some TV or play a game or something. That's quite easy. Easy going. So on that one. So here I want to exit because I was unable to find. So enum is missing enum value its value with the string. You cannot remove if you would like to remove. Wait, can you remove them? That's the question, isn't it? You can maybe. Nah. Yeah. If you'd like to change the enum, put the enum in dev mode. This will force a version upgrade. New line. Hint enum string name enum string name dev. Cool. So it's quite a lot of things. Should be right. So, and its value, so this has to just be duplicated a few times. So this one is the value though. So DST EV. Right, that should be it. That should be a nice hint. So if you have the source enum value, what you need to do is actually you need to check to make sure that the values match. And if the values don't match, then there's a problem. So if there's quite a few things we probably need to check, but if the underlying type changes, that too maybe. So we'll check the uint part. If that is not equal, then we'll print out a lovely error. At the source EV location. So has value this. Mismatch. In the database, it is this. Right, it's going to be printed out as like a how did I solve that problem before? See, in this context-aware printing is so much better. I just do it myself in a very nice way. Maybe we should make the errors context-aware printing, then fall back to doing printf. Now, but the fallback is hard. No, printf into a local buffer of so big, then run it through this. Yeah, we could do that. Should be possible. What's that exit thing? The exit message. Like, we're already printfing it into a local buffer. So why not? I think it should be quite possible. We'll just do a new line here. And then the message is going to go out into print format, which is our context-aware printing. And we'll just put the message out into there. And make this message a little bit bigger, to be fair. Let's make it 1024. Yeah, I think that'd be nice. Why doesn't that work? Oh. Damn it. Right, select previous function. Yoink. I want to get up to here. Yeah, but then we're missing a whole lot of stuff, damn it. Yeah, we'll just forward declare it. Yeah, so I think that can help us write out those error messages and not have to do that silly. Yeah, we'll just make it context aware. Yep, that's what we want. So we need to print out the file, so just stand it out. Nice. Cool. Yeah, that was location instead, didn't it? I remember now. Nice. So that's a good upgrade. So we can now. So what I could do is just make this a lot more simple. I could say, right, generator format enum is equal to this source enum, and then in here I could just say ident, and then I don't have to do this silly crap. That'd be cool. So this one, similar thing. There's a value version as well. Enum identifier. Value identifier for enum values. There's another one over here. Enum identifier. Right, so back here we can then get rid of basically all of this. This line completely goes. Because there's no... Oh, yeah. Now the beautiful thing is about this is was kind of like, how do we use the print formatting to print out an unsigned value or a signed value? Well, now that we're using our context-aware printing, we already have that problem solved. It's value. So if we look at the print format, our custom formatter, v will be like, what is the type class if it's assigned int, print it as assigned int, if not unsigned int. So that should be pretty good. Yes, that's good. So we're now catching, like, if the values mismatch for the same identifier, that's a big problemo. In the database, it's this, but in the encode file, it is right. So we can't actually. Yeah, we can't actually print out the two different values, but we can tell them what it is in the database, and then they can look at the source file at that thing. So we'll do dstev here. So we can do like two of them. That's okay. If that becomes more of a problem, we can always extend our system for that. If you'd like to change it, put in dev mode, this will force an upgrade or something, right? Yeah, cool. So next one is we would like to change this here, EMI. VI. EI. And then cool. Very nice. So now it's got to figure out what are the errors what other things can cause us to error if we have for enums. Now it's line. Ah, did you catch it? Thank you, if so. Oh, this is okay. In the database is in the database as a strut. Please use a different identifier. Yeah, it definitely wasn't English. That's cool. Yeah. So mainly it's just the grammar, but yeah, this is all right. This will still work. Thank you. Right. So I might take a quick break actually and go and get another drink. And then when we come back, we'll finish up on the errors for the structure. Oh, sorry, for the enum. And then we'll move over to doing the ones for the for a structure type or table types. Yeah, right. I'll be right back. So enjoy the tunes until then. Right, welcome back everyone. Yeah, so just got myself a nice green tea with peppermint. That'd be a nice little drink. I didn't want it to be a big thing. It was just more frustrated not being able to communicate properly. That's cool. No worries. Appreciate you pointing that out. I oftentimes don't write coherent English. It's quite common because basically I say it out loud, and my brain, when I'm like typing out, my brain's like, "Oh, I've said the words, therefore I don't have to." Yeah, I skip words basically. So, or yeah, I always need to do a second check, but I'm sure that's the same for a lot of people. Um, yeah. So looking good so far. So we're checking to make sure that the uh your if you have a different kind of type in the database, it will error. If you find the type, it's going to go over all of the enum values in the destination or in the database with all the values in the file. If it finds the one if it finds the one inside the encoder file that you edit, we then do an evaluation. If the value mismatches, we error. If it doesn't find it, you've removed it and you've not put it in dev mode, right? What other things could there be? So this is finding when you've removed it, one's when you add. So the problem is this loop isn't going to get it. We could do another loop, but that'd be another sort of n squared complexity, which is kind of bad, right? You know, if you get 32 by 32, that's 1024 searches, right? So it's quite, what iterations? It's quite a lot. And it just, yeah. So we've tried to help that by using hashes to make the comparisons quicker. So it should be okay. But we don't want to introduce another n squared complexity, right? So realistically, we should mark all of the fields to say this one has found one, this one has found one, and then we just go over this array again and make sure that it has so what we should store in the enum value is we should store a boolean or something to say, or you know, what's the maximum number of values, right? It's going to be 64. I don't know if we're going to go over 64. So why don't we put in a little bit of a thing to say, well, when you're parsing up the enum, yeah, when you parse up the enum, oh, we'll do it here. We'll do it here. If destination enum values count is greater than 64, we'll just be like, we'll print out like this is more than 64 values. I don't know if I'm ever going to need more than 64, but if we do, that's okay. We'll come in and sort it out. So it has more than 64 values. And the generator has not accounted for that. Yeah. So the reason why we're going to have a 64 limit is so we'll have a bit set, and it's just an easy operation just to know if we have visited all of those. Wait a minute. It's in the source one. Source value found bit set 0. Yeah, it's good. So here we'll say source value found bit set. I think I've got a function for that called bit set. Take the address of this bit set. Run out loud. There we go. And the bit index source value index. So that was set in the bit set. So then at the end we can scan over if in the bit set if we find one missing. Be a nice quick check. Ooh. I'm not sure how this best should work. Fair play. Bye bye, pal. I think this guy is like, 14, Sounds 14, right? Apologies for anyone who witnessed that. Right, so yeah, now we've got a nice and easy check, right? We can make it a little bit quicker by saying, the bit set has to be equal to 1 shift left source E values count take 1. So all that's going to do is just make a mask. So each bit within this 64-bit bit set is going to represent a value, so bit index 0 will represent that we've found source enum values 0 and so on. So if all of the bits, so this will get us all of the bits switched on for every value. So it's going to say if I've got 32 values, it will switch on 32 bits. If it's got 25 values, it switches on 25 bits. So it shifts 1 left by that, then takes 1 and turns all the bits on before it. So if it's equal to that, it's okay, it's safe. Right, we found them all. But if it's not equal, there's a problem, and then we'll do a little bit more of expensive code, which is fine because we're just going to crash the program anyway. We'll find one of the actual fields that we didn't find in the database, which means you've added a new field, right? So we can then use a super lovely function called least significant bit u64. So this uses count leading zeros or something like that. I always forget these things. But it's an intrinsic on the CPU. So it's just one instruction, and it can find you the index of the bit which is not set. So we have to not the bits to invert all the bits the other way around. So yeah, count leading zeros. Count trailing zeros. I was getting confused. And then on Windows, it's this intrinsic bit scan forward. A little bit funky. But anyway, so this will get us the index. So we know one of them is missing, so we'll do it anyway. Yeah. So this will get us our field index or value index. And then we can simply perform what we need. Source enum values source value index, and we'll take that lovely address. Enum identifier has a new value. New value identifier. If you'd like to change the enum, blah 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 blah. Right. That's pretty alright, isn't it? Yeah, I thought I was gonna have to do a search, and I realized I didn't have to do a search, so it's probably not that bad. We could probably do that here. Yeah, oh well. Maybe even that, yeah, maybe even younger. So we're removing an enum, removing an enum value, adding an enum value. So I think that's okay. Let's actually see an enum. So I think that's okay, right? Yeah. So we've got this whole dev thing, right? Dev mode. We still got to do the version number thing. So I'm going to leave the dev mode out for a bit because we'll actually solve it all together, I think. Right, what will be the next thing to solve? So if a whole enum gets deleted from the file, I assume we probably don't care about it anymore. Right, if I was to just delete this entity type, I don't really care about it anymore. Yes, that's probably okay. So deleting and adding whole enums are probably fine, or even whole struts. Like we'll just simply ignore the data when it gets parsed up or something. Like maybe we've defined another enum, or I don't know. Cool. So I guess let's do the same thing for the structure and the table, and then we'll move on to doing the dev mode thing, which will do the version numbers and that. So we're just basically going to copy paste this, and then sweet. Has at least one new one, right? One new what? Sorry, I'm misunderstanding. Has one new? Right, so I'm just going to rename enum to strut here. Right, too many. Cool. And then capital V value is going to be renamed to field. Cool. And then lowercase enums gets changed to strut. There's quite a lot of these boys and girls. I think that's all of them. Nope, we missed some more. Sweet. Oh, there's still some more here. Nice. So after renaming those, we've still got to sort out these things called like source E, right? Really, that should be called like source S. So source E. Your bit set detection for enum fields, you were looking for one or more changes. Yeah, that's correct. Yeah, so we'll print out the first field. Yeah, so this one here, we're saying if the source, if we didn't actually pick up all of the all of the source values when trying to verify them, then it must mean that there must have been an added one. So then we're going to find the lowest bit which is not set. So it would be the field which is closest to the top, and we'll just, or the value which is closest to the top, and we'll print it out and say that one is a new one. And if there's more, right, this is still errored and not actually done anything. So if they correct this one, then there'll be another error that will pop up afterwards, and then next run it. So maybe we could actually print out more of them, but I don't think that's going to be too much of a problem, but we'll see. Can always change it later, I think. So the final one is a thing called value, lowercase, needs to be changed to field. So a lot of these boys and girls. Very nice. Then where it says EI, it's got to be renamed to SI. For structure identifier. Awesome. That's good. We did kind of mess up here a bit though. Whoopsie. Oh well. There's also another one called EV, which is enum value and stuff like that. But we'll go ahead and correct it manually. So let's go from the top. We'll go over all the structures we find in our encode file. For crying out loud. We check the destination type tables. This is the database. Does it have a type in there that's already been declared? And is it not a structure? If it's not a structure, we print out and say, hey, it's been found as this other kind of type. All right. We should probably have one called table as well, I'm thinking. But they are the same. So a table is like a structure, but it can have optional fields. It's kind of a bit like what flat buffers does. It was a kind of cool idea, so I decided to take it. What the crap is this code? All right, look over all the struts and see if you find one. Right, this isn't the fastest code, obviously. Right. We need to check if it's a table. What else? Right, so we want to be able to know like what kind we are. So type kind, source kind equal source structure is table, type kind table, type kind strut. Right, so that source kind is not equal to the found type kind. Let's join the lines. Right, that's better. So we actually need to correct it still in so source kind. We'll get to that in 1 minute what that was. But this is when we parse the actual encode file. We need to do that same thing. Is table yeah. Very nice. Right, so back to where we. Oh, what is this? Right, struct cannot have a table type in it. So we've got a lovely thing called table now. So we don't have to do the check. Yes, that's made that a little bit more simple, isn't it? Well, a little bit. Right, we're back around again. That's good. So we sorted all the things out. So back to here, we're actually doing the type table merging again between our database file and our encode data description file. They basically look the same, but one has all of the previous history in it. So we've done this thing now where if the type kind is different from the one in the database, report an error. DSTE. I'll rename that. Cool. So did I So we've got another one called like SV now, underscore SV, underscore SF, structure field. Cool. Right, let's keep going. So that's good. So it picks up the destinations, the one in the database. We check to make sure of it. You know, if it's got more than 64 fields, we've got to change how we do our thing in the code generator, but it's not a problem to solve for today. 64 fields is quite a lot, so we should be okay. Really 128 will probably be safest, but so if we found the structure type, oh, this logic is extremely wrong. This should be done way earlier, because this is going to like be a null pointer reference. Right, so let's correct the one in the enum then first. So the enum one, we'll get rid of this. We'll say, well, if you ain't found it. If not found type, paste that in. Now we're going to continue. So it's going to add it to the database. Not found, add to the database, and then this can all just go on in a nice way. Right, so the same thing for the strut. This is the code you saw me edit earlier. Basically, if we've not found the structure type, it's a new structure, so we'll add it in, and then we shall continue to the next structure. Cool, so let's just get that all into place. Very nice. So what's next? So we pick up the... Yeah, so now we go over all of the destination structure fields. Don't know why that doubled up there, that's a bit weird. You may wear two cursors, I don't know. Go over all the destination fields, get out the structure field, get out the structure field, identify a hash, go over all of the source structure, right, the one in the encode file, and compare the hashes until we find a match. When we find a match, set the bit in the bit set, say we've found it. If the structure field exists, we need to make sure that their types match. Yeah, we need to make sure their types match. So thinking about it, we've got to make, if the types, oh shoot. So if we want to make sure the types match, the identifiers have to match, not the, yeah, the identifiers have to match. So maybe we make a type string and just make sure they're equal. It's a bit of a crap way of doing it, but it does help maybe. So if you do a type string of the, and then maybe we could print out as the error message, right? That they're different. Hmm. Yeah, it should be okay. If we add renaming, the VLA won't work, though. The VLA ident will be different. Yeah, but if we add renaming to structures, that would also be different as well. Yeah, maybe we won't support renaming for a while. Or what ways around it are there? So you would have to go to the so the problem with this merging is that if you take a structure field, it's got a thing called a type. And a type has, like, these are okay, because these are like enums or whatever. They're built-in enums. Whereas this strut index or enum index, you're going to have to patch. You're going to have to do some patching. So, maybe we can. Yeah, I think we can. So when we store the new, so that will only happen if the type is a new type, right? If not, I think it only happen if it's a new type. So if it's a new type, like one of these here, we actually need to go over all of them and patch. Go over all the fields. So we get the new, strut index, that's good. What are you looking for? Nah. Yeah, so you're looking for, in your destinations, you're going over all the fields and you're saying if the type kind is equal to a table or a structure or an enum. So I guess we'll switch it just to make it a little bit easier. Table or an enum. And I guess the rest we won't do anything about it because it's not really complex types in any way. But you need to patch. Here you need to do a super lovely patch of the those indices, right? So you need to do a lookup. So you get the identifier. So it's a little bit different for... so you get the identifier. Well, you do a find. So you want to do like a type table find source type table. Destination structure field. It's a bit of a bugger. Source struts data destination structure field type strut index dot identifier, and that'll get you the type. Wait, you want to look in the destination and then get that strut index. You get the structure index for that type. Then we simply say, okay, destination structure field type dot strut index equal that. It's a little bit expressive, shall we say, but you know, I could break it down a bit. Wrong one. Type ident. There we go. So it makes it a little bit easier to read. So we'll do the same thing for the enum. So that just patch it. So we might have to do some more places. Yeah, there might be more places where we need to patch, but we'll find that out. Right. So when you add a new type to the database, you need to patch, but also there might be some cases when you're in dev mode, you need to merge fields in. So actually, yeah, so we should probably have merge field as a function. So strut field, because when we're going to have to yeah, I think that'd be sensible. Because if you have you're in dev mode, you add or remove stuff, you're going to want to copy that over and put it in. DST structure field. So it shouldn't need anything. Oh, you need the destination type table. DST. Type table. Right, so we've got this DSTSF. We'll say field, whereas the other one is going to say, oh, these ones look in source structures. We need a source and a destination table. Right, that's looking good. Like that one. So there we go. So let's hop back to, yes, let's solve that problem now. I forgot what the problem was now. What piece of code made us do it? It was when we want to, yeah, the problem is when we code generate, if we've merged two structures, or taken a structure and put it into the new database type table, the structure indices and enum indices would have been wrong because they would have indexed into the wrong type table. Well, yeah, there would have been indices for the other type table, so we've patched that for that reason. But also when it comes to, oh, there's some other reason as well, but I forgot it now. Maybe we'll get reminded when we read this here. So yeah, we're going over every structure field in the database type table, and we're seeing if that a source field, if that the field exists in the .enc file, right, the encoder data description file. If we find it, oh yeah, we wanted to check for type equality. So now we can check for type equality pretty easily. We need a function for that though. So we have a thing called type string, but we'll make another one called like type equal. Or maybe you call it compare. I don't know. A and B. If A kind not equal to B kind, return false. Yeah, so next one is actually a switch statement with a kind, I guess. So I guess we'll leave some of this stuff. Yeah, maybe we'll just do a bit of a return to be fair. Right, so basic return A basic equal B basic. Packed return A packed. Ooh. We could do a mem compare maybe. Hey Ross, compiler, you make it like a variant type. Yeah, this type kind is a variant type. It's like a tagged union. So yeah, we already have one. Yeah, it's just got a type kind, and then we just have like one of these fields will be the right one to use based on the kind. So if it's strut, it'll be strut index. If not, it'd be, you know, enum will be enum index. Which wouldn't really matter technically, but yeah, the other ones will. But yeah. Right, so that's 0 initialized, so we should be able to mem compare all the padding bytes. Well, technically the padding bytes will not be zeroed. So, thank you, C standard. So we'll do a core 0 element. Right. So, back into the merge code. There's a thing. Oh yeah, it was type equal, wasn't it? Yes, in type equal, we can now just do mem compare. The address of B packed, size of A packed, and you got to say equal 0 because it can return minus values and positive values, and 0 means they're equal. So these guys want to return and say strut index equal strut index. This is enum index. Enum index technically doesn't matter, but might as well. Other is a string compare between A other and B other. So effectively we don't know. So the other field, right? Let's explain that. We don't know every single type in here, and if we don't find, if it's not one of the built-in types, or it's not a type that's been defined in this file, it's going to be cast as other. And so weapon ID here is an other type, and it's just, you just get the string of it, and we simply just, you know, plaster the string down when we do the code generation, because we don't really need to know about the values for others, right? That should all be done passed in, what, you know. Is that right? Yeah, we should, that an other type, you have to manually write your own decode and encode functions for it. And that's all it is. But there's a common use case where we're going to do, we can sort it out some other way. Maybe we could do some code generating for types that exist outside the system in this file as well. Right, that could be nice. We'll see how what problems we come across. So for an array to be equal, you need to be able to do a type equal between a array. Right. Well. Oh, no. If you want them to be equal, they simply just need to be... The array indexes need to match, is that right? No, because every single time you make a new array type, it just adds one on. Which reminds me of that merge field function. I need to sort out arrays. So if the field is an array type, you need to get just append into the destination table the array. What did we do that? Where did we do that before? Yeah, push array. DST array equals source arrays field type array index. So we copy that into there, and then we've got a patch. We've got to recursively call the same function, array element type. Yeah, some of that stuff could be messed up actually, Gotta be careful. Right. Let's write it down. VLA field index. In field merge, something like that. I'm probably going to forget that. Yeah, so I would like to say field type. Oh, what are we doing? Yes, an array could be an array of an array of an array. So realistically, we're trying to say, maybe is it called merge type? Because the field doesn't actually matter here. Type, good. So in that case, this would be, right, type table merge type, destination type table, source type table, the address of this element type. So recursively goes down there and patches that. Bearing in mind, we should have updated this type array index to be whatever the next index would be of the next pushed item. Ah, that was something. So we've got to quickly change that merge field to merge type. Right, so we was doing that type equality thing. Right, so when it comes to arrays, they would have been successfully merged. Ah, yeah, so we can't really check if two types are equal because this way, actually thinking about it. So in that merge code, my main problem was like we're going over all the structure fields and we want to make sure the type's equal. But if you've grabbed one from this encode file, so you pass this encode file, you've got your structure fields all in a lovely array, and you got another file which is the database. Kind of looks like this, just a little bit different, and it has its structure fields in a different array, and it's got a different type table. So it's as if you need to do a merge type and then check for equality afterwards. Yeah, I think that's what you need to do. That'll be alright. It's still possible. So my concern is with the array types though. The array types do really suck because we just keep appending them. So they're actually not deduplicated at all. So checking for array equality is basically saying making sure each well, is this just a whole mem compare really? I think we can get away with a mem compare as long as when we make these type things that all the padding is zeroed. That's my main concern really. So I think it's not easy. Yeah, because we could probably just mem compare. Right. All right, here's what we're going to do. I think it's safe to say that all of this can just be mem compared. No, but that pointer will be different. Yeah, okay, no, it's not. My mistake. So we'll call it array. A array. But you need a type table now. The type table would probably be the destination one only. Yeah, it'd always been the destination, the database one. Hey Ray March, how you doing? How's things? Ugh. Right, so we should just be able to do an equality check based on, it's a little bit funny, but it'll be A array equals B array elements count and A array VLA field index. That's going to be a problem, but I've put a note down for future me to look at it before we finish up. My brain cannot be bothered with that problem yet. Field ident. Recursively go down. Address of A array. Element type B array. Element type. Would you look at that? So this needs to do a core string equal. And voila. Cool. That's it. So that's the type equal working. So now we can check for equality between two types. Doing good, spend some time with the family. Cool. Then back to the code grind tomorrow. Nice. How's the ellipsoid BVH going? It's on pause right now, but it's good. We'll get back to it in about 8 months' time. But we're going to be building some editors first. So we're going to be building a... Ever seen the plan? Well, I've got a video that goes over it. Wait a minute. Is that what it is? No, obviously not. Oh. What's my command? Huh? Info. Obviously. I got the video which goes over it. There's a game tech plan. So we're done the entity system now. We're doing the encode decode system. We took a little bit. We've done a little bit more of a complicated approach. But it's good. But I was hoping of doing a very simple one, but it would have been so much more extra work later on, I guess. But yeah, the sort of plan for the next 8 months is to build some editors to actually, so we can actually produce some content. Because I've got a very custom renderer, isn't it? So I want it to be all in game and everything. So I'm sort of just getting some of the systems in place, like this encoder and decoder system and an entity system, which we've done. A quick and dirty asset system, so we can just find and replace code later on. You know, gizmos, won't need much work on that. Making a way to pick a color, and then start off on a material editor, which is the most basic one, and then basically making models out of ellipsoids in the editor. We'll see how much of this I actually do. There's more things. Your dreams before vibes, kinda. But yeah, not as feature rich though. But yeah, I definitely like the idea of being able to, you know, having it all built into the game. It's gonna be awesome. And then afterwards, I'll get back to some more BVH stuff. because then we could focus on actually making the content look good and really finalizing on that rendering art style. Yeah, and then we can move on to actually try and make a game. But that's not for a good while. That's cool because there's lots of fun on the way, at least. I like you plan to do something big like that. It's cool watching people build big, ambitious projects. Yeah, man. Like, you know, um, I've tried to build lots of like little game prototypes, and I've not really been interested by them enough to take them far enough. And I like building my own technology and stuff like that. I feel like these days people don't really build their own tech. So, I think it's great. Like I was thinking more today actually, and probably yesterday. Like this thing that I'm building will probably not be for just this project. I probably want to make a few projects out of this code base. So it is an investment for more than just this project, and I think it's going to have some tooling that I could probably give to the users to sort of make their own content with. So it really is going to bring a lot of value, and I think if you're trying to make a game these days, if you just make some old game and it doesn't really have anything that's to stand out, you probably the likelihood of doing well is less. So I think by doing this investment and sort of having different ways to stand out with this sort of ellipsoid BVH renderer, having this sort of custom tooling around it and people can use it, it should really sort of help make the, rather than just having a bunch of like, projects clustered here, because they basically are all the same. My project will be over here, it'll just be a bit, it's different. So it's clearly in its own little, well, not in its own world, but you know what I mean? It's not just lumped up with everything else, hopefully. Hopefully it's a little bit more distinct. That's the hope. I have seen someone actually do it. I've been referenced that there's that old game which did ellipsoid base rendering. And I knew I wasn't going to be the first person to do it, but I haven't seen anyone I haven't seen many games try and do it since and go all in. So, but maybe there has been. Having a unique set of start conditions makes it predestined to be quite different. Yeah, that's true. Also, just building the technology is fun, and I like learning stuff. I like putting, as much as sometimes struggling so hard really fries my brain. Like I like learning a lot of things and improving and getting better. Yeah. Yeah, I guess so. I'm glad people are enjoying it, and yeah, I'm glad people are enjoying it, and hopefully learning some things as well. And I also learn from you guys as well, especially especially when I do something new and get stuck on maths. But yeah, how's shame going? So right, when we're merging structures, we've got to make sure. So found an identifier, we've got to make sure that the types match, right? So we should really have one called like DST type, and it's gonna be like we're going to run it through. Wait a minute. Merged. So that'll be equal to source structure field. You know, we could probably merge it in place. I do not see a problem with that. No, we'll do it locally on the stack. So take a copy. We run that merge type. Oh, for crying out loud. That merge type function. Destination table, source table, and merge type. So that will make sure that all of like the structure indices have sort of like mapped over nicely. So we can simply do this. Oh, wait a minute. If destination if not type equal address of destination structure field type and address of merged. Right, be good. We can go ahead and say we've got a type mismatch. Structure field type. That's right, got a bit of a T, I think. No. Format. D for data type. Right. Type mismatch. Yeah, type mismatch. The database in the database is FD, right? I guess you can just check it. You gotta change the structure, put in dev mode. Done. Right. Nice. So this one, make sure if the field is missing. Yep. And then this one, make sure if the field, if there's a new field. Wait, this is VI. Hang on a minute. And this one is. That's good. Right, so there's one more check. And I think it's to do with the if the kind is a table. I think we gotta double check still. It's doing great. Feels like I'm getting closer and closer to release, but obviously the final stretch always ends up being quite long. Yep. There's quite a lot of the if it compiles, it runs idea in it. Obviously, not 100% it, but most invalid configurations that render pipelines are compiled errors. Awesome. Yeah, I do get what you mean. There's a lot of things, to do. And then sometimes when you go and fix some of the, you start fixing some of the problems, you need to you discover more. They either do right then and there, or you add it to the to-do list. Yep. But that's cool. It'd be great when you get it released and then you get back to your game. Start using it. Tiniest little sentences in the spec become a weekend of work. Oh no. And then you got to decode what the languages say. But at least on that final stretch, though, it's very good to hear. Like, you're not bothering with too many big features now. So that's cool. Did you hear something truly amazing, which has made my life far easier? My compiler compiles to SpearV, and DirectX 12 is gonna SpearV. They're ditching DXIL, which I was going to reverse engineer if I was bothering to do it. And they're replacing it with SpearV now, because they were probably like, our DXIL was using a very old version of LLVM IR, and you know, I'm sure that the driver vendors were probably like saying how they want to be using a newer version of LLVM, and you know, maybe they in their drivers took the LLVM IR and the DXIL one and moved it to the newer one or something. I don't know what they would have been doing in there, but I'm sure they use a stack of LLVM in their drivers to compile pipelines or something. There must be, because I know that AMD does it. But I'm sure everyone does it because it's just the easier thing to do, say. So I'm sure they were probably thinking, like, we need to update our DXIL to use a new version of LLVM. And they were probably just like, you know, but SpearV is here. So I'm glad they're doing this. This is great because the SpearV tooling is generally really good. Like, I was able to write my own little compiler for C really easily. The tooling was great around it. There was one or two designs about SpearV where I was like, this is terrible, but I understand why it exists. But the rest of it is amazing. So I really like SpearV, so I'm glad they're doing this. All they got to do is drop the whole of DirectX and just use support Vulkan. You know what I mean? That's what someone said in the Discord. It's good take. Yeah, so DirectX is using SpearV in the future. It's still going to come over a few years because it's going to be a bit of an effort. They're going to have to write some extensions to SpearV. But it should be a net positive for everybody, including if you use DirectX or not, because I'm sure some of those DirectX features which only exist in DirectX might come into Vulkan now, like resource descriptor tables, whatever they're called, and maybe work graphs. Those might come into Vulkan because they've got to support them in the SpearV levels. People might just be like, why not? Let's make it a thing. So, you know, I believe this could be a net positive for everybody. I think we are in the blessed. All we need is get Apple on board. But yeah, so my shader compiler now just has to export a slightly different version of SpearV, right? And voila, DirectX support. I don't know if I want to do it, but it's possible. Yeah, pretty great, isn't it? In it. Right, so you got this default value thing. That's about it, innit? Oh, is hex. Is hex don't matter. We can ignore that one. Doesn't matter. Oh yeah, if you got is hex, you want to copy the is hex over. So because you're merging, you want to say DST structure field is hex equal source structure field is hex. Oof. That's another thing as well. You might want to hex. Gonna add features as we need them. Right. So this a table. Well, We didn't care if it's a table or not because the strut, it should be 0 initialized. So checking for equality between the default value. And this thing says strut here. It's not correct. Right. If we can make another one where we say like SK. I would love that. SK would be very helpful. Course strings C, lookup type kind, strings. Yeah, we're gonna get the format. That's all right. Strut is table. Right, I thought it was something different for a moment. So I've got to delete the other stuff that we just put in. Nearly there. Alright, so that'd be helpful. So back to the merge code. There's a super lovely thing where we do this. Just do $SK. So that'll put in table or strut. Yep, because we've got the context aware print formatting, which is a godsend. Absolute blessing. Oh, you got it. Sweet. Yeah, spread the news. Spread it wide. Let's just run MonVK and let them deal with the problems. Yeah, but I guess you're not... Probably it's like a translation layer. That's the issue with it. So if you really want the good performance, I guess it might not be a problem for most games. MonVK. And maybe Apple won't be as nice to you if you port the game to their platform and use MonVK. They might be like, this is pretty neat. I like it. So we want to make sure that the course string equal if the destination structure field default value is not equal. That's another breakage, I think. Rightio. I think it's set in an FV. Yeah, that's it. In the database, it is one of them. Nice. Yeah, so I think we've done the validation for structures, tables, and enums, and doing the merging. Let's just double check and make sure we've actually sort of like merged. What is it? Let's make sure that we've actually done all of the merging side of things, I guess. We've done the validation. So creating, yeah, we either create the new entry and continue, or we simply just validate it and sometimes do some merging of things. So the enum one, that was completely okay. So for the structure, if it's a new one, we just put it in there, make sure the types get converted over. That's fine. Then if not, just validate and make sure that there's no fields added or removed. Or, yes, that's the thing for tables. Fields can be added and removed, kinda. Yeah, they can be added and removed, but they cannot be a different, you can't change the data type. So for a field, yeah, we've got to think about this problem actually. Yeah, it is quite a small platform. The hardware is pretty cool though. Like the strength for the battery life was quite good, wasn't it? But Intel recently released a new Intel laptop or mobile chips. Which ones? What are the latest ones? There's a new set where the battery life is way better. It is Lunar Lake. Yeah, that is it. Lunar Lake battery life. They actually get like really good battery life because they've no. Yeah, they can deliver battery life more than the new MacBooks because they've basically got their chips fabricated by Texas Instruments rather than them doing it in house, and they've actually decreased the I forgot what you call it now, but they've done like a full 4 nanometer um, transistor size, I think. I forgot what it's called now. So they're able to like be more energy efficient. So maybe the Apple hardware ain't that good, actually. You know, the old clunky x86 is still alright. Yeah. Texas Instruments, right? Is that what it is? TSMC? Is that what it is? Is that what that? No, it isn't. Okay, my mistake. It was probably these guys then. Yeah, TSMC. Yeah, TSMC maybe. Yeah, this. Yeah, that sounds about right. Yes, they were able to produce the Intel. Has been cranking out 3 nanometer chips for a while over a year now, but it's initially reserved for Apple. Is turning its attention to Intel. Oh yeah, 3 nanometer, actually. Pretty insane. Gonna be nuts. So yeah, maybe the Apple chips aren't really that great. Just it was just probably the process size or whatever they call it. Right. So for tables, let's go to the encode file. So tables, without changing the version, you can delete and add new fields. But the problem is if you change the name, your data is not going to like. Oh yeah, I think it'll be okay. Yeah, if you change the name, your data is not going to automatically carry over. We was going to support like aliasing and that, but I can't be bothered to do it in the first version. If I really need it, we'll do it. So if you add or remove fields, we should probably... So if you've removed a field, we need to mark it in the database as hash removed, right? But if it exists, yeah, so when we do the code generation, we simply don't, wait. Yeah, so when we do the code gen, we can handle that case. But if the field has been added, we'll just, do the, yeah. Yeah, so actually, this is going to say if type kind strut. This is when we've added a field, so we're going to error. No, field is missing. I think it's called source kind. So if it's missing, it's a problem for structures. But if it's missing for tables, we probably want to say removed is true. So that would be like a hash removed, we'll encode that as. And they'll only be available in the database files. Yeah, so else destination structure field is removed equal true. So if it exists, is removed equals false always. Rest will change. Yeah, so if you bring it back, it says removes is false, and then we can do some type mismatch stuff. Sweet. So for the adding, so for this one here, if you add a new field, we only really do this if it is actually a structure and not a table. Cool. That's pretty sweet. So for the remove stuff, we should really do the parsing for that as well. And we should really have a way. So I think I'll call it parse file. We should know whether this is a is database or not. So we're parsing the database file, parsing the encode file false. So inside this file, when we parse up that sort of hex directive, I think it is, we could parse up another one. This one is called the removed. So we can say hash remove on the field. And then we can set the is removed to true. So in the database file, that will be preserved. But here we should do an error and say if if is not the database file, we want to say hash removed can only be used in is internally used in the database files only. Cool. So we've got that in there, so that will get parsed up, which would be pretty sweet. So let's go back to that merge stuff to see if there's anything else that we're missing. So you merging the tables. Yeah. So I think we could do the versioning stuff now. We haven't really done versions yet. And dev mode, that sort of thing. So we've got a bit of time. Well, why don't we just see what happens when we encode it out? Yeah, let's run it and see what happens. Yeah. What else? Oh, a seg fault. Right, so that's a valid pointer. Is found type invalid then? Bum bum bum. Oh, this is if not found type. Crap. Whoops. Let's correct that. Right, so we've not found a type. So we're trying to look over all of the fields within this structure. Yeah, that's it. Right, a bit of a copy paste error that was. Right, so apparently that ran successfully, no problems. So we have this new lovely test encode database file, which should be here it is. So you'll notice to set the language. If we do a vertical split of source logic. Right, so here's the two files. You'll notice that the one on the left is more explicit. It has the, oh, we didn't check that, did we? The underlying type. Yeah, the underlying type must match. If not, we need a version upgrade. But yeah, so the underlying type is there. This implicit value was explicitly done. And also the ordering might be a bit different as well. If it would put enums first, then struts. And this is wrong. We need to correct that. And we'll do that. So let's put that the check in for that thing there. So the type, the underlying type must match. If sort dste underline type, that's just a basic type, so if that's not equal to the underlying type, EU will do the underlying type, right? So we can then set, we'll do the destination. EU underline type mismatch. EU in the database, it is this. Right, we should really save it outside the database. It's another one, but I can't be bothered. It's good enough. You can check in the file at this location. You'll find out. There's also the problem when we printed it back out. So when we print out the database file, when we print out this array type thing, where is it? Print filled data type. See, it's a bit of a bugger, right? Really, the arrays need to go here on the right hand side of this. Because if I look in that database file now, the way it's printed it out is the array goes before. Right, we could change the syntax to that, but then it's not C-like. And I want to keep it as C as possible. So this should really go here. So it's a bit of a bugger to sort that one out, to be honest. So you need to we could have one which says print so you want to print like the underlying data type, right? The sort of the base data type. And then so I could say B and then I could say A for array. It's a bit sketchy, but we can do it. B, we'll make another one called B. So in here we'll say F $F. So we're going to have new ones which sort of, we will need to have a way to resolve the type and skip out the array. Maybe we'll say like no array base string, we'll call it, and then we'll call it the array string. And that'll be the A ones, A, B, and we'll find those. So I think the way they're going to work, so there'll be a base string version, which is going to do yeah, I guess we could just say for all of them but the array, call into this one, type table type, delete all this, not delete, sorry, delete all the contents of these, they'll bunch up into one. There we go. So we don't have to duplicate some of the effort that's going on here. That'll go like that, and for the array one, it is simply just gonna call the same function but on the element type and just ignore the array entirely. Okay. Um. Gotta forward declare. Right. So I think that's all right. The other one we want to do is the one where it says just display the array stuff. So that one would be like this. So these will just return an empty string. Yeah, call string null, that's what I was looking for. Huh. So return a null string, so don't put anything down. But for the array part, you just want the array stuff, right? So you do the one that's inside first, followed by the one that's outside. Right, so that'll be the correct printing now. So let's take that one for a spin. Bear in mind we'll delete the database file because it's going to start erroring otherwise, maybe. Right, so now that's made the new one. So let's go to the Encoder database file. Do a reload. Boom. So that got corrected, which was nice. And yeah, we handled that error, but cool. So I guess we could take the we could have a bit of a go and just make sure the code that we've written errors, right? So if we open up this is the database file, so we go to the non-database one. If I were to add a new thing, so it's got this dev thing here, which will technically mean we could change it, but I've not implemented the dev stuff yet. So if we add a new field in and call it pig, let's watch that happen. Oh. So it failed to parse the database. So that's because right, I got it. It's doing this, and that decoding is buggy. So well, we do that in parse file. there's a on the enum, right? Enum identifier. What? That's weird, isn't it? That should work. So it must have spaces somewhere, you know? Let's put a breakpoint in here. Quite loud. There's a big old flying thing. We're going to take that out. Be right back. Right, I've lost the bug, but I've got this now. Whenever it comes back, it will be annihilated. But until then. Right, so we run that now. Oh, found it. Yes. Got it. Right. Breakpoint. So what's the ident? Damn it, it's got a space before it. Ah, of course it does. I didn't skip the white space. I thought I read it as skipping white space, but I didn't. There you bugger. Right, skip the white space, and voila. Did we not put... line 19 of the database file? Ooh. This syntax is not a supported thing, is it? A default value, eh? We shall probably omit that, maybe. Yeah, let's not put it in there. Right, so what we're going to do is... where do we do that? When we save out the database file. Either you have a default value or you don't. Yep. So if we delete the database... oh, I need to go back to the encode file then. Right, so let's remove pig, and we'll put pig in. So let's delete the database file. No. Now we're going to run the encode generator. That will produce a database file. Now we add pig in. Now we run. Duplicate enum value 0. So that's when it was encoding. Oh yeah, of course. Because yeah, it's right back around to 0 again, isn't it? Let's say pig is equal to 77. Put pig in there. See, if you just add new ones, is that a problem for enums? Oh, look at that lovely error message that we added today. Isn't that great? Enum ent type has added a new value ent type pig. If you would like to change the enum, put the enum in dev mode. This will force a version upgrade. Int. Nice. Pretty good. But if you add an enum value, right, that in and of itself is maybe not problematic. But you might... so we could support adding and removing individual enum values. But if the enum values change, that is a problem. But then what happens if you deserialize a value that you have removed, right? It doesn't make, you should really keep it around, because then the enum will be in an invalid state that you probably need to handle, right? Whereas you know this, you know the states then, right? So say if you remove a frog from the game, you keep the frog around unless you do a version upgrade and you do the remapping and that. And then in that case, it'll throw away the data, wouldn't it? Maybe. I don't know. Well, yeah, it's up to the version upgrade what to do. But you keep it around. In this case. So if you add a new one, that could be problematic by maybe you have an array. So if you create a new piece of data, I think this is where it is, right? On a newer version, if you make a new piece of data on a new, and then which has the pig in it, and you give the file to someone on an old version, they will load it. Pig is not going to be a known thing, so it will fail. And it won't be able to say, it will, the error that you would say is, the pig enum doesn't exist, so I've failed to decode it. But that's just equally the same as saying the version 2 is greater than our version 1, right? So technically that's not really a good enough reason for it to be a problem. So the other thing is, I guess, is that count thing that we mentioned. Is that a big enough problem for it to be an issue if we add stuff? So if we add new enum values, See, I don't think it would be a problem, right? It'd be really annoying every time we add one value to increment the version and you have to do upgrades. Quite annoying. So I think it's wise, we can add, fine, but if you delete, that's going to be a problem, right? I think that's just good. So that add side of things should actually be removed. So merge. So in the merge, there's that check, right? There's a new enum value, this one. We can delete this code now. Wait. We want to go over all the new enum values and put them in. So this is where we're going to do the super lovely loop. I think it's anding it with the -1. Yeah, that's it. Neat. Right, here we go. So I'm going to go over all the bits that are not... we could do it the other way. We could set all bits on. Nah. So not in it would have turned the bits on which were not found. And that includes the ones at the end. Um, so let's OR on the bits. Oh, that's an error waiting to happen. It's a U64, innit? That'd be like an overflow, and that'd be a right bugger. Right, so we should be able to do a thing where we say we're going to set the high bits for the fields that do not exist yet. So we'll say U64 max, so that's all bits on. Shift me left by the number of values. So that will remove all the low. So set all the bits for values outside the range. Outside the outside of the enum values count. So now we can do the loop. So we can say while we have some bits, so we not it. Oh. Whoopsie. Yeah, we not it like so. So we invert it. Now we're trying to do some merging, right? These are new enum values that don't exist but need to get merged into the database file. So you get the next index and then you remove the least set bit by doing this and equals the -1 of itself, and that will remove the least set bit. Maybe I should have a function for that. Return v and v take 1. Boom. Pretty nice and readable. So that's how you do a super nice loop. That's how you do a for loop over bits in a very cheap way. You can use a single instruction and get the least set bit index, then just remove it, then you get the next one. So it's pretty cool. Yeah, so what we're looking at doing here is actually adding fields, right? So it's quite, it might be quite involved actually. I've got to have a think about this one. So unfortunately, I think we might have to So we found ones that have been removed. That's okay. Right. These are the new ones. So we should realloc. Wait. Maybe you just realloc and copy the source ones over because you've checked to make sure they're okay, isn't it? We could also just, you know what? Maybe we don't need this at all. This is overcomplicating stuff. It might be as simple as this. Destination enum. Just copy the array pointers, and it should be okay. Because we don't really... Yeah, I don't think it'll be an issue. The only time it'll be an issue is if we try and work out like an index from it. But we don't do that yet. So I think it'll be okay. I don't think we'll do it at all. So we're going to say here, the enc file could have added, right, let's say if destination enum has added new values. You know, we'll just copy them. Just use the source enums arrays. This shouldn't be a as inserting them will be too problematic. We have to because we've got one big array, we have to insert them into the one big array and then chase all the other pointers. It's quite annoying. So this will do. Right, so I don't need this bit set thing anymore. That's okay. Right, so that was no longer problematic, but we reached another problem that for some reason there's a type mismatch on the array field. So our array check encoders actually doesn't work. This final field here, so close. So what's the problem? So we can check that in type equality. So here we just put a breakpoint and we can figure out what the hell's going on. So hit the breakpoint, op in there. There's quite a lot of crap in it. Right, so let's get both in there. P dereference B array. So these for some reason are not testing as equal. Oh. B is zeroed. Oh. We're looking in the encoder database type table, that's why. No, it should have worked. Merge type would have ran. Right, that's a bit weird. Merge type should have ran, and then it should have copied the array over. Right, it probably didn't update the array index. So merge type Nope. Push. Ooh. There's your problem. Old array index we need to be using. And that should be it. Right, I need to move that breakpoint. I love good old programmatic breakpoints. Cool. So apparently that ran successfully, no problems. So what were we testing there? Well, that just loaded up the encode database file and was able to parse it and merge it successfully with no problems. But it also added a new enum type, and we'll test it again. Sorry, a new enum value for an enum type. So let's make sure it's correct. Right, doesn't appear to be. Seems to have messed up. Pig should be there. I don't see no pig. Let's go back and see if we can find pig though. Right, pig is here at 77. Oh, wait. Reload. Yes. Right. I forgot to reload the file. So pig showed up. So if we go back to here and then let's add a new one. We'll call it mouse or something. So it's going to add a mouse 78. So run the generator, reload the database file, mouse 78. That's cool. So let's test changing the underlying type. So I'm going to say, hey, you're a U32 now instead. Wait, I'm going to say you're a an S64. Because why not? Right. Ent type, underlying type mismatch. In the database, it's an S32. Right, we could make the error message a bit better, but ought to be good enough. So that's pretty sweet. Then I can put it back and it restores fine. That's good. So let's go back to the database file, reload it. Nothing's changed as we expected. So that's cool. Enums are pretty solid there now. We're in the encode file now. So we change the structure by removing a field. What happens? Error, strut is missing the field health. If you'd like to change the type, put the strut in dev mode. Nice. So we change it to a 8-bit one. Is that a problem? In the databases, it is U16. So it hasn't really put the name of the field here. The name of the field would be helpful. And also, we didn't test changing this. Save frog is 12. Yeah, see the frog is in there, right? And database is 1. Yeah. So we'll make the error message a bit better. Merge. Strut field data type. This one. Dollar $S field I. Right, let's get back to that encoder file. Yeah, we didn't save it, so right, it's better. Field health type mismatch in the database is U16. Cool. That's great. What else? Adding as well was another one. So if we add a U8. Oh. What about moving? Realigning fields. That might be a problem. Yeah, here we go. So we've added a new field. Yeah. Cool. So for structures, for text decoding, it's not a problem. For binary decoding, we're packing stuff. So they should really retain the right order because it's going to create problems. You would have to look at the type information and reassess which one to do first, and then have the decoding code would just be a bit more problematic. So yeah, we cannot support moving fields around in struts. That's another error check that we need to put in. So for after you've done you need to say if it is a structure, I'd like to do one more check. And we'll just go over all the destination ones and we'll make sure they're all in the same order. So we'll do something like this. We'll go get your so this way they would have been guaranteed to be equal length. So this should be safe, what we're doing here. We just need to make sure that the identifiers match. So it's a simple case of this. Destination strut field hashes field index. If they're not equal, we're going to say, right, we want to say there is a, values have moved around. DST SF. Oh yeah, I don't know why it went that far. Whoops. So SK, so that should be strut. Well, I can leave it in there. No, we'll do it. So we want to say this field has moved. Field has been reordered. Nice. That would be pretty sweet. So if we try that now. Right, so that ran successfully. Let's hop into the encode file. Let's grab the health and move it after the strength. Oh. We got a sig fault. Oh, whoops. We didn't set the context to where printing, so it looks like it's ran successfully. So we need stuff like this. Cool, let's try that out. Boom, there we go. So strut entity field health has been reordered. Oh yeah. Right, so I think that's kind of it now. The default value change. Tables can be... Yeah, we've got to test tables being added and removed, isn't it? So we tested changing... Adding and removing fields we've tested. Yep. For structures. So for tables, we support removing, and they get the remove flag. We need to check that one. So for tables, if I delete health, run it, it runs successfully. I go to the database file, I reload the file. This should be marked as removed, but it hasn't been. Right, here's why. Because I didn't put it in the serialization code. So save database file, right? We just go over everything and just write it out. We've got this if hex thing here. I need to do the same thing and put remove in there. Removed, like that. So now we've got the new version in there. We can try it out again. So if I delete the health from the table, I run the script again. We hop into the database file, reload. Damn it. It says strength is marked as removed. That is completely wrong. And it's marking... Huh? I don't get it. Let's save that one back out again like that. Right. Go over all the destination fields. If you don't find a source field, mark it as removed. Seems legit to me. Let's rerun that. Maybe there's a bit of invalid state. Maybe I didn't reload it before or something. I don't know. Let's look at the database file. Still the same problem. Right, save that back out. Right, that's a real big big weird thing there. So I don't know what happened there. Right, this time we're putting the breakpoint in there. And we're going to investigate. Right, we hit the breakpoint. Did we? You bugger. Oh, we never hit this breakpoint. So where's it getting the removed things set? Oh. Yeah, so if it pauses removed. Crying out loud, that should be it. Right, let's go back to the database file and let's remove the just save it back out again. Right, reload, undo, save. Why didn't we hit the breakpoint? That's a clear problem there. So it doesn't exist. In the source file. The type kind might be, no. I don't know if we've got a hash collision. Maybe. But it's happening in two different types. Which is the most craziest thing. But we could check to make sure, you know, if it's a table type. Put the breakpoint down and we'll just check it. Right, let's go back to that database file. Right, so I've saved it back out again, removing that removed thing. So we're going to put in a special bit of code to say, hey, if source kind equals a kind of table, drop that in there. And right, so finally hit the breakpoint. So what's the problem? So the first one is going to be the coordinate. It finds the coordinate, no problemo. Right, actually it won't be that bad of an algorithm because they'll stay in the same order most of the time. Yeah, that's good. Right, then it goes around to the next one. This one is a health. Looks for health, not that one. It is this one. Wait. How do you exist? How? Did it merge? Hmm. So you get the structure field. Does it exist? Oh, I put it back in there. Whoops. Wait a minute. If it's back in there, how was the other one? Right, so strength is not even getting picked up for some reason. Right, let's go into strength. That's probably the issue. What's the next one? Right, strength. 1, 2. Should be this one. Finds it. Yep. That's strength as well. Yep, good. Is removed as false. What is going on? Well, if I carry that one on, it will... database file. Damn it. I feel like it's uninitialized memory. Then. Let's get me on that one. Right, let's try that out then. I think you change the condition, you have something like is X. Oh. That's probably it, Albert. Thank you. Copy paste. Yeah, copy paste is like the what causes most bugs, I think. Copy paste. Like the fact that you have the paste feature. I gotta remove it from the database file now again. Right out that version. Good. Boom. So just reload. Yes. Thank you, Albert. Appreciate it. Appreciate you, sir. Right, so now we're going to remove a field. So we go to the non-database one, right? The regular file that you edit. You delete the health from the table. Run the script. All works out all right, apparently. So I then reload the database file. It's got the hash removed on it. Bam. So if I were to add it back in, then shoot. It is 100 space. No. Right, so I need to not take that space in there. Close though. Yes, it's a default value. So it's everything up to like the semicolon or whatever, but we should trim the space off the end. Yeah, then we should, while I don't really have a trim function, but here we go. Here goes nothing. There could be a whole bunch of new lines in there and everything. I'm making a trim spaces function. Core string trim. I'm just gonna do. Let's do both ends. So I guess you have two versions, right? One trims from start, one trims from the end. So you just say while string dot size. String dot data. Let's get the char. If char equal space, or char equal new line, or char equal carriage return, then we would like to carry on. If not, we're going to return our string. So this will be like string take 1 and then data plus 1. That's a trim start. Trim end. So trim end is going to be the same, but string size take 1. And then we want to take 1 from the end only. Then trim is just going to call, string equal core trim start. String. And then end. And return the string. Like that. The power of string slices. Cool. So that should fix our problem. Right, default value had a space character on the end. Big problem. Right. Still an issue apparently. Oh, I didn't do a continue. Whoops. Hmm. Uh. Hmm. What? See what the value is. So SF default value. Dot size 3. That's correct. Ah, so the database file would have put right. So it's correct now, but the database file has got invalid data in it, so we've got to change it. So no. That's fine. That parsed space. What is it in the what? Okay, so I think the comparison is actually wrong. Right, so what are these two? Oh, that was a macro. I want to put the breakpoint here. Where ran successfully? Right, let's put that back there just in case. I am confused. Why did that work? So Encoder database file. Right, removed, not removed. So it did recognize it in the end for some reason. Right, so let's go back to the actual encode file. We're going to delete it. Put it back. Yeah, so delete it just fine. It puts the remove flag there. We restore it back. Right. Apparently it works now. I don't know what it did. That's weird. So if I put a bunch of spaces here, it'll still work. Good. So if I change this to 101. Right, we hit the breakpoint, which is where the error is going to display. Yeah. In the database, it's 100. Cool. So we can reorder stuff in tables. That's okay. You're allowed to do that. We cannot change data types. Yep, that's a problem. What else can you do? You can add and remove fields, right? But if I add, yeah. But now I've added that field, it gets committed to the database, and if I re-add it again with a different type, it's a problem. Cool. Right, I think we're actually there. That's pretty incredible. So today we've got the database file working. So we're able to serialize that out and do a bunch of checking, which is really cool. The one thing that we're still missing though is the versioning side of things, and that's what we'll do in the next stream. So the code that we've done today, I'll put it up on the GitLab for those who are supporting the stream. Thank you very much. That'll be up there. If you guys have a play around with. And next stream, which will be on Tuesday at 7:30 p.m. GMT +1. We'll get the versioning side of things done, so we'll be able to put it into dev mode, right? Play about with some values, and then remove dev mode, and boom, you got a new version. And that's gonna be 2 separate enums which get code generated, and then you've got to provide an upgrade function for it, right? So we haven't done any of the code generation stuff yet. We're still doing that. I just wanted to get the whole system in place, because the system is kind of the heart of this design. So I wanted to get something in. So it's basically there now. I just need the versioning, and then we can code gen. So next stream will be versioning, and just making sure we're ticking all the boxes, I think, with this system. And then we can do the code generation. So we'll generate CSON files, that's a C like JSON, binary files, which we've done the binary serializer. And then we've got to do a third one, which we haven't done yet, and that will be for GPU stuff. So it's more of like an in-memory packer. So I might call it a memory packer or something, I don't know. So that one's going to be, it's not going to be bit packed, it's going to be byte packed probably. Well, no, it's bit packed, but they're going to be aligned. Aligned to a byte boundary or something like this. So you'll be able to have an in-memory representation of the packed structure and unpacked structure and do the conversion. So we'll be building stuff like that as well, for the code generator side of things. So probably got one more stream for the versioning, 2 more streams, maybe 3 for the code genning, and then we should be completed. Well, there's going to be stuff we'll need to add, but it's pretty much there after that. But yeah, coming along very well. I like the fact that this file is basically the same, but so we can reuse the serialization stuff, which is cool. And if I try and put hash removed into here, it's going to be like, you know, oh, oh, we don't support 2 directives. Whoops, it's meant to be a while loop there. Anyway, we'll solve that one in a future stream when I need to. Right, let's bail. Let's find someone to raid quick. I hope you all have a good start to your work week. 228 Hooligan, eh? He's popped by a few times. Seems like very Russian though, so maybe not a good idea. Because English audience probably. And most people would just not understand. Bro, we just got Dennis. Doing a bit of CPP, let's give him a raid. I see you, PP. Right, good to see you, Pete Riggs. Thank you for popping by. Thank you for popping by, everyone. And I'll see you all in a future one. Much love. Catch you later. Bye-bye.